I surely believe in the existence of talent. I believe people are different, people start from different starting points, that we all have different abilities in different fields, that it differentiates us. It's just not productive to deny this. We see it in our daily experience, we can confirm it from our daily life. Nonetheless, I do believe that the most important determining factor for success at something, or for mastery, or for developing a strong intuition for something that you're learning, is interest. This is not something that I think. A ton of people can confirm this by personal experience, and more importantly, it's supported by scientific research. Yeah, I can conceive of the fact that there can sometimes be limitations of why you cannot be the best at the thing that you want to do, but I am 100% sure that your interest alone is gonna get you ahead of way too many people who are in the field just because of another extrinsic motivator. I even have a personal experience that confirmed this. Let me tell you about it. When I was young, I was terrible at math. All my family members thought I would never learn mathematics, and I thought I was dumb. In 6th grade, we even had a private teacher come to my house to help me with math, and illegally, before the day of an exam, he showed me the exam, he solved it with me, every single question, didn't tell me that that was the exam so that I don't go to school and say, hey, the teacher gave me the exam, and I went the next day to the exam, and then I got a 3 out of 20. 3 points out of 20 points that one can get on an exam I solved the day before. The teacher was shocked. He told my parents. I did everything. I even showed her the exam beforehand. It wasn't until after 10th grade that I started developing an interest in math. And that was because, guess what? A good teacher. A good inspirational teacher. And then I started researching on my own, watching YouTube videos, learning math, only because I'm genuinely interested in learning this thing. And guess what? Now I have a minor at university in math. I take all of my mathematics courses with mathematicians, with the people who study mathematics, and I study physics. And now comes the interesting part, namely, to what extent is learning and mastery affected by interest, and how much is this backed up by scientific research? In 2014, this amazing group of researchers published a very fascinating paper exploring the role of curiosity and motivation in memory formation and learning. Based on the proposition that motivation, curiosity, interest leads to better learning, there were 3 main research questions that this paper attempted to answer. The first question was whether the areas in the brain that light up during a curious experience or during experiencing curiosity are the same areas in the brain that are responsible for external reward, or that get activated by external reward. External reward being something that excites you from outside, like food, money, or whatever. The second question was, what exactly does curiosity do in the brain that causes better learning? And the third question was whether curiosity leads to better learning, even if the thing that you're learning about is not the main cause of this curiosity. So whether being in a highly curious state per se is actually what leads you to learn the stuff better, and not necessarily that you are interested in the stuff that you're learning. Now to the findings of the paper. They found that being in a curious state actually activates some areas in the reward center of the brain, namely the nucleus accumbens and some areas in the midbrain. They're called like the substantia nigra ventral segmental area complex. Not only that, but also being in a curious state activates the interaction between these reward centers in the brain and a very cool area in the brain called the hippocampus. The hippocampus is basically the memory center of the brain. And this answers the second research question, namely curiosity activates the reward center in the brain, which interacts with the hippocampus and then enhances memory, so you learn stuff better, you retain the stuff that you're learning better, and hence you learn them better. What they also found is that incidental learning took place, which means that as the subjects were learning the thing that they were curious about, they were exposed to some other information that are not really that interesting, and they were able to retain it better because they were in this high curiosity state. Hence, the proposition was right. Curiosity leads to better learning. Another relevant study was published in 2007 by 3 scientists. One of them you probably have heard of because she published an amazing book which I would strongly recommend called Mindset. The study was exploring the influence of students' core beliefs about intelligence on their academic performance at school. The group of students in question were transitioning to junior high, which is a pretty challenging stage in one's life, a stage where societal challenges come that were not there before, and where coursework at school change and you start comparing yourself to other people. And also biologically, they are going through puberty and they experience changes in the brain where areas that are responsible for the development of the reward center and and social sensitivity mature faster than the areas responsible for self-control and long-term planning. So they are at a very difficult stage. So the idea was to see how much their beliefs about their intelligence affects their life, basically. So to achieve this, they did two studies. The first one was purely observational, which means that they didn't intervene in anyhow. They just observed students over 2 years as they're transitioning from 7th grade to 9th grade. The second study was an interventional study, which means that they actively did something to change what's going on. So in the first study, they observed 373 7th graders and divided them into two groups. One group was the entity theorists, which are the group of students who believe that intelligence is fixed and you're born with what you are gonna always have and you're done, basically. The other group were the group believing in something they call the incremental theory, which means that they believe that intelligence is malleable and that you can change through hard work. What they did find is that the first group experienced a flat learning curve, or a flat achievement curve, because they would monitor this through grades. They would look at their grades. Their grades stayed basically the same. And the other group experienced improvements in their grades. Their grades went up. So that was the first study. The second one, the interventional one, they had a group of 48 students, which were the experimental group. Experimental group meaning that's the group that received the intervention. And another group of 43 students, the control group, the group that didn't receive any intervention. The intervention that the first group received was teachings about brain plasticity and the fact that the brain can change and that your experiences affect your brain and stuff like this. The second group didn't receive any teaching like this, and the quality of education for both groups were the same. One group didn't have better teachers in math, and then the other group. What they found was that the experimental group, the one that received the teachings about the brain and stuff, they experienced an upward going learning or achievement curve. Their grades improved, also like the first study. But the second group, they experienced the opposite, unfortunately. Their grades declined. What we can conclude from this study are two things. First, it's really important what you believe about yourself and what you believe about intelligence. Second thing is, your beliefs are not fixed. With enough training and through reading a book or watching some videos, educating yourself about the topic, you can change these beliefs and influence your life. So, are you now convinced that it's not just talent?